Hello and welcome to Captain Bob. Today I'm going to show you how you can make the Cessna Throttle and Mixture. Coming up.
Captain Bob, he's my best friend and he should be yours too.
My throttle design uses a 1/4 inch dowel with a 3D printed throttle or mixture cap. I'll leave the link to this one and that one in the description below. And then I designed this bracket for the potentiometer, and you can slide this here and then put this on top of and then slide the dowel into the other end of the connector. You can then tighten the screws and you have a working throttle. This part has a hole in the front for the throttle, and then I carved out a little bit of here for the pins on the potentiometer, and then you can put the potentiometer right in here. You can then screw or glue this face onto the panel, and then in front of that put one of the decorative nuts or bolts, I guess. So here I'm taking measurements off of this poster for the throttle and mixture position, and then I simply scale the poster up by 1.15, and then it will give the life size of the poster. So I can find dimensions from like the base to here, and then from the pedestal to here. So basically XY coordinates. I'm taking these all from the center because the sizes of the items themselves might not line up. So this is about 2.5 centimeters, and then this is about 6.5. Here's the paper I used to get the rough dimensions, and I'm just going to transfer this onto a better paper that has the right dimensions that are taken into the factor of 1.15, or basically multiply these dimensions by 1.15 to get the real Cessna dimensions. So I made a simple chart right here, and there's the values, and there are the measurements I took off the poster, so like 1.5 or 2.5, and then the dimensions that you get out for the real Cessna. So this would be times 1.15. So for 1.5, the out value is 1.725. For 2.5, the out value is 2.875. So now we can use these dimensions and put them onto the poster, and then use this as a template or a, I guess, roadmap. So 1.725, it doesn't have to be exact, would be, and then so right about here, then 2.8, that would be right about here. I'll scan this paper and leave it in a link in the description below. The first hole you want to drill is a pilot hole. This one's optional, and I'm using a combination countersink bit, and I think it'll work nicely. Any small bit will work. And then the next hole you're going to use is the biggest hole. This is the hole that carves out where the nut right here goes. You'll notice that the sizes correspond. The third hole you want to drill is one that goes all the way through, and it is the thread hole for the threads right here. You'll notice that the sizes correspond here too. You want to make sure with this bit that you leave at least 8 millimeters, or like a quarter of an inch, off of the panel, so you don't have it too tight where the panel breaks, and so you have something for the bit, so you have something for the friction lock to hold on to.
Captain, we're overspeeding. I know, bring the throttle back. It's as far as it'll go.
Your wiring should look something like this, and it probably will. It's not very easy to see where all the wires go, so I made a diagram right here. The one pin on the end of the potentiometer right here, the lone pin, goes to ground. The two pins right here, the pair, the left one goes to your A pin, or your analog pin, so A0 through A4 in this case, and then the right pin goes to 5 volts. So your wiring should look like this. I plugged mine into a breadboard so that the 5 volt would go to the positive rail, and then the ground would go to the negative rail, and then those would both transport to the pins on the Arduino. Since you're only using 2 potentiometers, you have 3 free potentiometers that you can use for wiring. And then on a circular potentiometer, the wiring would look like this. Your first pin would be 5 volts, the middle pin would be A0 through A4, and then the last pin would be ground. So that's with a typical rotary potentiometer. Now you can verify and upload AmStudio's sketch for the 5-axis controller. Go to Game Controller Settings, and then calibrate them. So now that we calibrated them, they work very smoothly, except for the Y through throttle axes. Those are completely random and often do interesting things. But that's their choice. We can't judge that for them. Now in the simulator, you can configure these as the Throttle and Mixture axis, and it'll work well because this is now a game controller, because it wants to. If it flips out, usually that's because one of the connections is not connected properly, or at all in the case of Y, Z, and throttle. Now I transferred the wiring before into the Cessna and just glued the Arduino Leonardo down here. This is a fairly temporary setup. Later I'm going to mount it horizontally, so like this way. I'm also going to shorten the cables so that it looks more tidy, and then it works the same as it did, just barely. We are in the Control Axes tab in the Settings Controls in FSX, and we can go to Mix, and we can go to just Throttle. Let's see, Propeller, Throttle, and that's the first one, so Z-axis, and that's perfect. Now we can also go to the mixture axis, and then do our mixture axis. So now we move that, and let's go to take off. So now the throttle and mixture works according to the sim. And you can turn it, it just doesn't do anything, but you got that going for you. Now that you've built your throttle and mixture, you can learn how to build the rest of your sim at my other videos. I have a whiskey compass and an instrument playlist. You can learn a lot there. And I also have a switch panel. You should go check those out. Make sure to like, subscribe, and I'll see you in the next video. Have a fantabulous day.